the table below shows the boiling point of 3 alkanes. What is the general formula for alkanes? So what we're looking at here is we're looking at a formula where of this type. So CN, H, and then whatever N is going to be here. So let's make a little table over here and put these results in. So I've got N there. So if N is 5, so we can look at just the C's. So C, N, 5, 10, and 15. And over here we've got H is 12, 22, 32. So what do I need to do to each of these here, these numbers here, to make this number here? Well, it's not N, and it's not quite twice. If I double 5, I get 10. If I double 10, I get 20. Double 15, I get 30. Okay, so it looks like it's almost 2n, but then I've also got to add 2. So the general formula is going to be CN H 2n plus 2. Okay, so it's going to be of that form there, and I need to work out what this was going to be, remember. Explain the trends. Explain, so it's a describe plus the trend in the boiling points of the alkanes. So we have 3 marks, 1, 2, 3. Okay, so I need to say here what's going on. So the first bit is going to be, remember, describe. So explain is just a describe plus. So as the alkanes get bigger, what happens to the boiling point? Well, it goes up. So as alkanes get bigger, and I might say as they got more carbons or more hydrogens, it's fine, but just as they get bigger, boiling point increases. Okay, so the boiling point increases. Well, why is that? Okay, because, so this is, now if you think about, I've got all these, think about how boiling point, remember I go from a solid to a liquid. There's my solid, but I'm going to change that into a liquid. So what happens when I change it into a liquid? Well, I need those intermolecular forces to get smaller. Okay, so as alkenes get bigger, the boiling point increases. This is because the forces holding, and I could use the word particles here, I suppose, but I'm going to use molecules because we're talking about molecules. I know what they are. Holding molecules together increase, so more energy is needed. Okay, so the intermolecular forces increases as the forces increase. And where am I going to get the third mark from? Boiling point increases that because the molecular forces increase as the slope. Okay, this is because forces holding increase, so more energy is needed. In fact, that's probably what I needed for that bit there. Turn my phone off. Increase, more energy is needed. And I'm not going to link that across the energy actually. The higher the temperature, the more energy is provided. Okay, all given. Okay, I'd probably get all 3 marks for the first 2 bullet points alone there, but again, I've got a situation where I want to explain exactly what's going on. I think the diagram helps as well, just to remind myself what happens when things boil. Okay, turn from, in fact I've gone boil, I've gone melt, haven't I? Sorry, when they boil, it goes from liquid to gas, doesn't it? Goodness me. Okay, so we're going from boiling to gas, from liquid to gas.